is Leslie and I'll be your instructor in this tutorial session. Today we're looking at PostgreSQL joins, and it's important to understand what's the concept of joins as we are dealing with a relational database. Joins usually are used to combine rows of two or more tables together based on the relationships that exist between them. Now, and the reason why this concept is very crucial to us is because um, while we're working on a relational database management system, we are going to be working with a lot of tables that um, have relationships between themselves. And it is important that if we have to extract data from one table that has a corresponding data that resides in another table, we will be able to combine such data together, to get the desired results that we are looking for. And that brings us today into our PostgreSQL joint. And of course, if you are new to joins, you may have been used to the fact that you oftentimes query data from one table at a time. But in this particular case now, you'll be querying data from multiple tables, and you're not just going to get multiple results, but you're going to get a single result. This concept will help you understand how to access queries from multiple tables at the same time. And the query that can help us access multiple rows, of the same or different tables, what we refer to as the join queries. Join queries. In SQL, joins are used primarily to query data from one or more tables, of course, based on the relationships that exist between several columns in those tables. And the tables ought to have a column that has a relationship with another table. So what I mean is, if I have something that uniquely identifies me and I have to be represented elsewhere, that entity that uniquely identifies me can be used in the place where I can be represented, not necessarily saying that I must be there, but by virtue of that thing that represents me being there, it means that I am there. So that's just the concept of join. And in joins, it's important we understand what a primary key is. So a primary key is a column, or of course you can have multiple of them, or a group of columns with unique values, for each row. It is the property that gives each row its uniqueness or a unique identity. Now, the purpose of having a primary key is such that if you have a primary key that identifies the records in a particular row, it can serve as a point of connection in another table where you would want to refer to those records, but instead of bringing those records into that table, you can reference just that key. Of course, in another table, that primary key becomes a foreign key, just as I am, let's say, a nationality of Nigeria, and if I go outside the country, I am a foreigner. So that is how it works. In another table, that primary key becomes a foreign key. However, whenever it is called upon, it still has the ability to connect every information that exists in the table where it originally exists into the other table now. So let us look at the proper understanding of what a primary key is. So here we have a customer ID that identifies uniquely each customer in the customer table. And we have a second table called the payment table that shows us the payments that are made by customers at several period of time. Um, Here we have a customer ID, and let's say we're dealing with a particular customer, 524 Jared Ellie. So Jared Ellie is uniquely identified with the code 524. So whenever this code appears in the payment table, it means that Jared Ellie is making payments. And at this point, we don't necessarily have to refer to the name Jared Ellie anymore, but we can refer to the code 542. Now, this column becomes your primary key because it is the column that uniquely identifies each entity. And then when these keys are represented in another table, for instance, they are called the foreign keys. So that is the basic understanding of the concept of joins. Let's look at what we call the inner join. For instance, I'm going to refer to pgadmin as time goes on. Now, for Postgres inner join, we have a table called our customer table, just like we saw, in the previous slide, and the table called the payment table. Now, by matching the values in the customers and the payment table columns, we are carrying out an inner join of both tables. And what this inner join does is it examines each row in both the first table. So assuming we have two tables, we'll call this our first table, which is the customer A table, and the payment table, which is the customer B table. What it does is it compares the values in the customer table. So it compares the value in this customer table. So it uses the customer ID column to compare the values in this customer table and the customer ID column in the payment table. So it compares both of those values together. And if these values are equal, the inner join creates a new row that contains columns from both tables. And of course, it adds that new row to the result set. And we're going to have a mental picture of this. So this is how an inner join works. So I have my table A, I have my table B, and I look for what connects both of them together, and I create a new result that has a combination of both of these tables. Now, of course, the connecting points of both of these tables. It is good we also understand the syntax of the inner join. So we have our select. Where we're selecting from, we're selecting first from we're selecting our columns now. So we're selecting the customer ID column, we're selecting the first name column, we're selecting the last name column, we're selecting the payments column, payment ID column, and this payment ID column is coming from the payment table. So we're selecting the first name, the last name, the customer ID from here, and also the payment ID from here. And we're equally selecting the amount. Now, where are we selecting these information from? We're selecting it from C. Now, if you observe, we have this, of course, at this point is a prefix, and at this point is a suffix. So we have this here. This is an alias. So it helps you to identify the table from which you are querying that particular data from. So C, which represents our customer table, is just like a short form of course, customer. We're giving it that alias. So we can have, if you want to write it in full, you have customer dot customer ID, customer dot first name, customer dot last name, and the rest of them. But we're rather using an alias so we can have our query in a way that is less difficult to read. So we're selecting all of these columns from the customer table. So wherever you have a C in front of it, it tells you that it's coming from your customer table. we're selecting these columns from our payment table. So whenever you have a P, it indicates that it's coming from the payment table, and we're selecting these informations from the customer table. However, if we say we're selecting all of this from the customer table, how come are we including the columns from our payment table now? So what makes it possible for it to return the combination of columns from both the payment and the customer? We're introducing what we call the inner join at this point. So the inner join is that element that allows you to bring in this payment ID from your customer table, and also the amount from the payment table, sorry, the payment ID from the payment table and the amount from the payment table, combine it with the columns from your customer table, inner join, so payment, which has the alias P. Now you're inner joining the customer table and the payment table on. So on serves the connecting point. So you're joining it on this. So the customer ID, where this customer ID on the customer table is equal to this customer ID on the payment table. You can have one customer ID and many customer IDs, because this one customer can make many payments in either different days or different times of the same day. Then you execute. So we go into our PG admin, and I'm going to turn off my video for a while. Okay, so we'll go to our PG admin, and where we're going to write our table. I'm going to be working on the DVD rental database, and I have a couple of tables here, and these are the tables that I'm working with now. So I'm going to write a couple of queries, and while I write my queries, I'm going to also indicate my the question right here. We're looking at finding customers who made payments, and so let us find, let's call this example 1, right? So example 1, find customers who have made payments, and for this kind of question, the tables of interest would be our customer table and also our payment table. So it is important to note that a connection should exist between these tables, meaning they should have a column that they have in common. In here we have our customer ID table, and under payment we have our customer ID column as well. I'll indicate both tables. So table A in this case now is customer, while table B is our payment table. All right, so that being said, I'm going to write my query. To write my query, I'm going to select. So I'm going to select, of course, what do I want? I want the customer ID, and I want the customer first name. I want the customer last name. I want the payment ID. I want the amount that was paid, right? Now, where do I want to get all of this information from? I want to get it from my customer table. However, because I'm going to combine both tables together, I would, at this point, give my customer table an alias called C. Now, remember in the execution of Postgres, the from comes before the select. So at this point, an alias has been given. If I included just the alias at this point without including it here, it would return an error. At this point, The customer name has an alias, so I'm going to include it here. So to let it know that it's coming from our customer table, and the alias and a dot in front of it. Okay, so for payments, I'm getting this from my payment table. I'm going to give it the alias P, right? So even if we have not put it, so inner join. So of course I can use the inner join, or I can use join. So payment, I'll call my payment P on. So I'm going to write this here on. What is the column that connects both of them together? So the column that connects both of them together is the customer ID. I'll need to, so let me repeat this here. So customer ID, this will be my payment, and this would be my customer. So this is the customer ID coming from my customer table, and the customer ID coming from my payment table. If I execute this query, I have my result here. I can decide to say order by anything basically. So I can decide to say I would like to order this information by my customer ID, and indicate, just let's indicate with this. If I execute this query, I would see the outcome. I have the customer IDs, I have their first name, I have the last name, I have the payment, and I have the amount. Let us make a couple of observations. If I select all the information from, say, my customer table, if I execute this query, I have about 599 customers. If I execute my query for payment, please keep that in mind. I have 599 customers. For my payment records, I have 1,459, 14,000. So 14,596 payment records. If I execute this query again, I have a total of 14,596 records, meaning if we can see or observe that Mary, for instance, made a couple of payments. So Mary paid about um, about 30 times. So Mary has a payment record of 30. So she had made 30 payments. Of course, these payments happen at different time periods. And if we, let's expand the payment table, we have the payment date. So if we include the payment date here, we execute this query, it gives us an idea of the date Mary made this. So if we cast this, let's say it's date. Okay, so because they were all, some of the payments may have come in the same day. Let us execute this. It gives you an idea of the dates the payments were made. So this was made on the 14th of February, the 15th, She made payment twice. Yeah, most likely rented a movie twice. On the 18th, she rented a movie twice. On Of course, this was before the introduction of Netflix and, and the rest of them. Yeah, so she rented a movie multiple times on the 28th of March 2007. Yes. Okay, so that gives us all the information we need. We've seen the customers who made payment. When we observe, if we want any information from this table, we can actually save this table a um, as is a view and access it much later, or maybe as a temporary table and access the data from it much later. So let's continue with two or one or two more examples. So for my example two, I'm going to be looking at getting the list of inventory details, right? Or should let me say I'm going to get a list of customers. So customers, let us find out. Let's find out which customers rented um, which movies. We're going to find out which customers rented which movies from our inventory table. Okay, great. We would have to come up with a way of finding out which customers rented which films or movies from the inventory table. We have an inventory that keeps records of the customers that have rented movies over a period of time. Let us look for this information. Now, how can we achieve this? We would have to achieve this by, if we observe the inventory table does not have the customer ID. So the customer at this point, the customer here, this customer ID is not represented in the inventory table, but we have a film ID that is represented in our inventory table. And our question specifies or specifically states customers who have rented which movies. So if we are making reference to who have rented a movie, then that information will be found in the rental table as well. So you can see we're going to be combining a lot of tables to get the information that we require. And our customer ID is present in our rental table. Our inventory ID is present in our rental table, but our customer ID is not found here. So we would have to combine our rental table with the inventory table, and then we would combine the film table with our customer table. Table would be used to get the name of the customer. The film ID will be used to get the films which they have rented and will join with the inventory table, and the rental will be used to get the information of their rental and will join the rental table with the inventory table here. So let us begin the execution of our query. So I'm going to select customer ID, going to select first name, going to select the last name, I'm going to select the rental ID. I'm going to select the rental data as well to give me an information of the date the movie was rented. And now at this point, I would like to also select the film ID. And if I look in here, I can get the title of the movie. So let me use the title instead. So I'll get the title and I'll get my, say, inventory ID. So I'll know at what record, such information holds in the inventory table. Now, where am I getting all of this? So I'm getting this from my customer table. I'm going to give it the alias C, and I'll do the same here. This is customer. This is customer. And for rental, I'll give it the alias R. From here, R. From movies, I'll give it the alias F. From inventory, I'll give it the alias I. So I'm selecting this from customer. I'm going to inner join, start with the rental. I'm giving the rental an alias of R on. I'm joining my rental on customer. So I have a relationship between the rental table because it has the customer ID. So let's say this. So this customer ID equal, and I'll say R dot customer ID, because the rental, so I'm joining my rental table at the point where they connect to each other with my customer table. I'm joining the rental to my customer table, so by connecting my customer ID column on the customer table and the rental ID column and the customer ID column, sorry, in the rental table. Now that is my first join. I'm going to indicate another join. Remember, we have different informations in different table. So I'm going to join the inventory. Inventory connects my, so I have my rental, and my inventory table. This is my inventory ID. Now, next, remember we have our films table where we're getting the title of the movie, and I'm going to connect my film table as well. So at what point do they connect? I have my film ID and my film ID from the inventory. So I have inventory, I'll give it the alias I, film, I give it the alias F, and film ID is equal to inventory. So film ID here and connects to the film ID in the inventory table. And at this point, I believe our tables are connected properly. So Let me execute my query. Okay, so I have all the record, all the information that I need rather. I have the customer ID, their first name, the last name, the rental ID, the rental dates, the title of the movies, and the inventory ID. So I'd like to rearrange this table. What I can do, I'll take my inventory ID here before my customer ID. I like and also include my rental ID, and I can have my customer table. Then the date it was rented, the title. So I would like to see the title just after the name of the customer. Okay, so let me ensure I have all my queries written out properly. It's R, C, comma, rental dates from. Okay, so I've reorganized this. Let me execute it again. So I have the inventory ID, which gives me the information of the inventory, the rental ID, which gives me the information of the ID, in the rental table, then the customer ID. Now, the customer first name, last name, the title of the movie. So I'm going to use alias here. I would call this, I can use this as film underscore title. As film underscore title, and if I execute it one more time, I have the film title and I have the rental date. So I've been able to answer the question to find out which customers rented which films from the inventory table. I hope this tutorial was helpful, and if you have any questions, I'm more than willing to assist you in answering your questions. Thank you very much.